Yeah. So, as I said, we will be essentially focusing on these problems which want you to manipulate the information you have given in some way, shape, or form. Let's just start with like one classic example because we need to honor to the example. It's like the first one ever. You have a rod. Any guesses where this is going? I think everyone knows. Yes,
Rewind
it
the
is.
rod.
Yeah.
You don't need the rod, but like it's like yeah. Usually there are ants on these rods. Like that's an ant. But like we'll replace there are like 10 Shih Tzus on this rock. Yes, Shih Tzus are quite nice. And the point is like each Shih Tzu moves in one constant direction with a speed of say 1 meter per second. This rod is 10 meters long. Whenever two Shih Tzus collide, they simply reverse direction. So this will change into this. What is the time after which there is nothing on the rod? Oh, a Shih Tzu is a dog's breed. It's like a very cute dog. Yes, they are hairy. That adds to their cuteness. Either way, I think people know this problem, right?
Can you just repeat the problem?
I didn't know of this problem.
Yeah, there's a rod. There is a rod which is 10 meters long. There are 10 Shih Tzus on the rod, and each moves in one direction with a speed of 1 meter per second. Whenever two Shih Tzus collide, they reverse directions and keep walking this. So,
Alright, okay.
after how much time will there be no Shih Tzu on the rod?
Yeah, sure.
Or otherwise prove that at any given state there will at least be one Shih Tzu. Yes, it's ants, but I like this. I just prefer Shih Tzu to ants. So
No, I meant like the problem asks for something slightly different. But
wait, what does the problem ask for?
I don't know. The one I did, uh, it was like there's a queen ant, and after some time, all the ants are back at their original position. No, like the ants can't fall off. When they reach the end, they just reverse their directions. That was the first difference, and then like after some time, the ants are at the same position, and something probability something you have to do.
Oh, okay, this is not that problem then. Yes. So any ideas, people, to begin with? Like, just anyone. Okay, is there anyone who hasn't seen this problem before? You can raise your hand.
I mean, this problem struck with me so much. Like, I remember even the solution. I think, if I'm not messing up,
Wait,
you
Aditra,
just.
lower your hand. Yeah. Okay, so you people can think of the problem for 3 minutes and then I'll discuss the problem.
By the way, can we have buffer problems?
Oh yeah, sure, right. Buffer problems. I should get one. Wait, you can still only see the one note, right?
Can you please again repeat the problem statement?
Yes, just give me a second. Uh,
Can you give 16 IMO6 as buffer?
oh, 69 6. Wasn't that like buffer in Shreya's class as well?
That was buffer in Shreya's class? Okay.
I don't remember.
Oh, I don't know.
I mean, it
Oh,
I,
I
I,
know.
I,
Okay, I'll
you
give
can
you
use
a.
this.
This is one of my favorite processes problem. Uh, yeah, this should be good buffer. Yes, people, this is the buffer problem. How do I move it? Yes, this is the buffer problem. I will paste it here as well. Okay, Kushagra, the problem, you have a 10-meter long rod. Do you get it? Like you have a 10-meter long rod. There are
Yes.
10, okay, remove Shih Tzus, it's unnecessarily complex. There are 10 dogs on this. Okay. Each dog moves with the speed of 1 meter per second, and whenever, like in one direction, and whenever two dogs collide, they reverse their directions and keep moving. Okay. Did that make sense, Kushagra? I will take that as a yes. Oh yes, by the way, the source of this problem is 2012 IMO P3. It's a nice problem.
I think part A is nice. Part B is unnecessarily hard. Or I don't know.
Oh yeah, part A is good. Part B is hard. I agree. Okay, I will just tell you the solution to this so that we can move on to more interesting problems.
Yeah, it's just
So
ants which identities.
yes, you can just yeah, Aryan, go on, tell the solution.
Yeah, the ant just switch identities. So like whenever two ants are colliding, so they don't switch the identity. So they're like they still go the entire way.
Suppose that you have like dog A and dog B.
Yeah.
Now, whenever they collide, if dog B was going here, he will switch direction to this side, and this will switch direction to this side. So
Yeah. So
observe that these namings are completely irrelevant to the problem. So what we do is that we just switch their names. And this way, what happens that instead of colliding and switching directions this time, they collide and they just keep moving forward. So the answer is 10. Like after 10 seconds, there cannot be a single dog on the rod. Did that make sense?
yes.
Yeah. Exchanging souls is a bit unnecessary, but yeah, you can think of it that way. Okay, let's just do a nice problem now. Okay, try to guess the source of this problem as well. That would be nice. Is it visible? Is the problem visible?
Yes.
Yes. So, has anyone seen this problem before?
No, I'm not.
Okay. This is
Me
not
neither.
shortlist C4, Anushka. That's a different problem. That's a different problem. Have we defined process? I don't think we have. Okay, you don't really need to. Process is essentially a bunch of steps you do. In a process problem, usually you will be given a configuration and asked if a certain other configuration is achievable, or does the process stop at any point, and is it possible that the process never stops at all. So these are the kinds of problems you will encounter in a process question.
Okay, so process is like types of problem, right?
Yeah, process is a types of problem. There isn't a stringent thing here, and as it is a type of problem, many different ideas are applicable, like coloring, invariants, global local principle, everything. Yes, try this problem. Any ideas you get, you like feel free to speak out.
Okay, I'm pretty sure this is like some binary sorting thing.
Why?
I mean, like you're sorting them, and you're just dividing them into groups of two.
No, they need not be groups of two, right?
Like not groups of two, like any groups, and you're just sorting them. So yeah, I think it's like some merge sort of some sort.
Oh, it's not a merge sort actually. It's worse than a wait. Yeah, it's not a merge sort.
Bubble sort of thing, right?
Yeah, it's a bubble sort.
Yeah, okay, yeah, bubble sort, right? I forgot the name. some sort like.
Yes, it is some sort. I agree.
But now, if it is a bubble sort, then you can just apply the bound of a bubble sort easily in this problem, I think.
This
Can you?
isn't exactly a bubble sort, I think.
Wait, what does it mean to apply this process two or three or n minus one times? I mean, I don't get that.
Okay, so let's just do a small example on this test. Let's just look at the case n is equal to 5. Yes. So suppose you have 1 here. Okay, like as they have distinct heights, you can just denote the heights by 1, 2, 3, 4, 5. Okay. 3, 4, 3, 2. Okay. Suppose you are given this thing. Now, what it does is it splits into the least possible groups such that from left to right, they are arranged in ascending orders. So can you tell me what the groups will be here?
I think we'd have four groups. The first group has 1 and a 5. Then you
Yes,
have 4, 3, and 2 in their own separate groups.
that is correct.
Isn't 4, 3, and 2 not in ascending order from left to right? Acha, okay, in separate groups. Okay, sure.
Yeah, they have to be in separate groups. So now we will apply the process to this guy. We would get 5, 1, 4, 3, 2. We flipped this group, and as there is like these are single guys, there is nothing to flip. So we just keep them as it is. Then again, we do the same exact thing.
Yes, so the thing is that you see after some time the biggest number comes to the complete left. So you can just leave the biggest number and just induct down.
Oh no, like why does that always have to happen in small number of moves? Like why?
Like if you take a group after some number of turns, you
Yeah,
will find, because like whenever five is with some number, five will always, if you note that if five is not in the complete left, five will always be in a group of two, because any number in the left of five will be less than it, so it will be in ascending order. So five will always be flipped, and in every move five will come to the left. So
sure.
Yeah, so
after
essentially, like at every move, the 5 moves toward the left by at least one position. So after n minus one positions, it's at
yes,
the
yes,
extreme left, like that.
exactly,
Yeah, but
exactly.
like in these n minus one positions, you have to show that the other guys get sorted as well.
Yes, so five takes five, like five takes, I guess, four moves. Four takes three, three takes two, and two takes one.
No,
Once
but you
we
have to
have
show
5,
that
can we
this.
induct?
Yeah,
You can't, right? Because 5 will always require at least um like it will take 4 moves to go there, and you have to show that in 4 moves everything will always be sorted.
Yes, yes.
I
four
mean,
moves, everything will be sorted. Oh, okay.
yes, you can't do more than 4 moves. You don't want to do more than 4. So you have to show that everything will be sorted in 4 moves.
Okay,
And yes,
okay.
Bhairav, your idea is somewhat correct.
I was hoping that n minus we could just ignore the n minus one and then do, and then the n minus one will magically pop up. But
Oh yeah, sadly you cannot.
What if we say that like 4 moves to the left, by at least one step, except if 5 is in its group, and
Yeah,
5 will be in its group only one time, so it moves towards the left at least n minus 2 times. So it will be at the
at
second.
most 10 minus
Yeah, at
1.
most two
at
n
most,
minus
yeah.
2 times. So it will be at the second.
Yeah, but right, that shows that you can fix 5. And similarly, you can fix 1 due to its as it's the other extremum. But what about the things in the middle?
Wait, no, I said for 4.
Wait, for 4.
Yeah, like 4 moves to the 4 moves to the left by at least
Hmm.
one step each time, except for the time 5 minutes group.
That is correct.
And I think it can have 5 minutes group only once.
That is also true. Yes.
Yeah, so from that it moves by at least n minus 2 steps. So it has to reach at least n minus 2th position, except 5 is the n minus 1th position. So that's where it is.
Okay, can you do the same with this 5 instead now? Like you have 7, 6. Can you do it with 5?
What are we to try? I went for a little while.
Yes. So their plan is like they're trying to fix everything in like some amount of moves. They showed that 5 can be fixed in at most like 4 moves, and
Yeah.
they also showed that
Yeah,
4
so
will also. What?
yeah, so like when 5 is getting fixed, we have to show that everything else is also getting fixed in the way.
Yes.
Correct. Yes. So what are you trying to say? You're trying to do the same thing with the 5 here when the 5 is not the largest number.
Yes. Yes. Like now, okay. What they did was
Isn't
they
it
showed
already
that.
sorted? Bro, if this is already sorted.
No, I'm asking you have to show. Can we induct on the longest decreasing sequence? How will you do that, Aritra?
I'm not
Also, it would just
sure.
be better if you speak up.
Yeah. So I was
So
thinking like we take the longest decreasing sequence in the arrangement, and then we try to show that like every time we have like one more element on that sequence, something like that. And if we don't have that, then like we get some other decreasing sequence which is like longer.
yeah, I mean, yes, that's our idea, like kind of our idea to like yes. You're just trying to put
I'm
the
not sure though if we can show that, like if that is actually true or not.
I mean that is happening, but yeah, how will you show us the problem?
Wait, no. See, here the decreasing sequence initially is of length 4. Here the decreasing sequence is of length 3. Here the decreasing sequence is of length 2 only.
Oh, not
Or
not like that.
oh, then how?
So in the first case it is 4. In the second case also like 5, 4, 3, 2 are there basically.
Oh, so you ignore the one like why
Yeah,
did
yeah.
okay.
Because like if at the last it is like full n, so that will mean that it is like 5, 4, 3, 2, 1. We don't have to like do that if it is like at n at last. So like we don't care about that one specifically.
I see.
Well, we know that the last number after n minus one moves uh, has to come on the front, right? Yes.
Yeah.
Yeah, that's it. So
Okay, like,
Both the last guys have to come back.
yeah,
Oh,
so we can kind of forget about the last guy. We know it's whatever we're gonna do, it's gonna come in the last.
sure.
And we can probably work on this now, and then we can probably work on
yeah,
something like
the
Bhairav or
pro
Aritra's ideas.
the problem is that after 5 is arranged, you have n minus 1 moves already done. So you need to arrange all of them in n minus 1
We
moves.
don't specifically think about 5 and 1 as like numbers.
That's my
Basically,
point.
we
Yes.
try to think of the sequence being in right place. Like depending upon one number, that is like that will take too much time. Like it might happen that 5 and 1 is getting sorted at the last move only. So don't think about 5 and 1
Yeah,
like in
yeah.
a sequence, not 5 and 1 as like different numbers.
Exactly, Aryan. The point which you're talking about is looking at how to get 5 to the place. It's not the idea. We know that 5 will get there. Whatever we do, 5 will be there. So if we forget about 5 for the time being and look at everything else.
Yeah, that's what I'm saying. That you have to prove that even 4 gets in there in the same n minus 2 moves. And I think Riddhiman's idea was the best that shows that like you just forget about 5 for like 4 gets there in n minus 2 moves because or n minus 1 moves because the only place it shifts from the extreme position is when 5 is in its group. And every time it just shifts to the left. Like 5 always shifts to the 5 always shifts to the left. 4 shifts to the left 4 times. Like that minus 1 times because 5 it will only not shift to the left when 5 is in its group. 3 shifts to the left only again not only 2 times but every other time and so on. So if you do like this, you can arrange it. It will the entire thing will arrange as 5 goes to the left. That's what I think.
So guys, formally we can just induct, right? We can show that when we start with this sort of with this process, we can sort of make phi invisible, continue with the process, and this process will be somewhat identical when you only add 4 numbers. And by induction,
Can
we
you actually make 5 invisible though? Because whenever you have a 5, it will break like the sequence.
Wouldn't
What I
making
mean
one invisible be better?
No, right. Making either one of those invisible is somewhat a bad idea only. Because see, if you have 5, you can have okay, take this sequence. Okay, not this sequence. Take the sequence 1, 2, 5, 3, 4.
All right.
If you make 5 invisible, 1, 2, 3, 4 is an entire sequence. But
Yes.
we know that that's not the case here.
Yes. Yeah. You get it in clumps. Yes.
Yeah,
Exactly.
okay. So here what I was saying is shown, like, just if you consider 5 and just look at 5 throughout the entire process, it will get there. Now look at 4. Every time, even it shifts to the every move it shifts to the left.
Mhm.
If you look at 2, it will go to the right. But okay, wait. Okay, we have to even two goes to the right.
Oh, 2 and 5, like 1 and 5 are symmetric, 2 and 4 are also the same, right?
Yeah, 1 and 5 are symmetric. Yeah, 1 and 5 are symmetric, 2 and 4 are symmetric. Fine. So if you notice that 5 always goes to the left. If you yeah, if you make the group of 1, 2, 5, 3, wait, you make increasing groups. Yeah, okay, 1, 2, 5, 3, 5 and 3, 4. Like 1, 2 is a group, 5 is a group, and 3, 4 is a group. So yeah, so wait, does 5 go somewhere?
Also, other people also feel free to speak up. Okay.
Mandar, can we make the group according to us? Like
What?
in this, okay, 1 to 5 can be a group. Yeah, 1 to 5 can be a group. Okay, if 1 to 5 is a group, then however, like we are just flipping the order.
1 to 5 is okay. Yeah, 1 to 5 is a group. I agree.
Then how are we doing this? Like we are just flipping the order.
Yeah, you just flip the order. So this will become 5, 2, 1, 4, 3.
4, you see 4 goes to the left. Like 4 goes to the left, also 5 goes to the left, and 3 does not go to the left because it is with 4. Now every time it will go to the left. If you check in any move, it will go to the left.
Can you always guarantee like that 3 will only take n minus 3 moves to reach its place? Can you guarantee that somehow?
I mean,
with nine numbers, should that be
we
correct? Like,
we do have a buffer of 2 moves. We do have a
Yeah,
buffer of.
sure, you have a buffer of 2 moves, but how do you show that that buffer always exists? Also, Paras and Akshar, you were saying something.
Yeah, like can we induct on the like kth largest number? Like the k wait, yeah, kth largest number. Like if let's say n minus k can go to their respective position. So
Mhm.
for n minus k minus 1,
Mhm.
uh every number from 1 to n minus k can like send it to right only one times. And can we do using this idea?
That's a good idea. That's a good idea.
So something
So
like you're blocking off the lower numbers so that you can get the higher ones on top.
exactly.
Yes.
So here is the first thing we introduce. So what we do is induct on okay, and we make this sort of uh, optimization or something in some sense. Take the numbers from 1 to k and replace all of them with the digit 0. Take the numbers from k plus 1 to n. Replace all of these with the number 1. You have to show that after n minus 1 moves, all the zeros will be towards the right and all the ones will be towards the left.
but after n minus 1 or k minus
N minus 1.
1? Okay, yeah.
It seems kind of random though.
No,
Oh, see.
good,
Wait,
good, good.
firstly, do you people see why this is equivalent to the original problem?
Yeah.
Yeah, I mean, I
Wait,
think that's fine.
wait, not because like once you put all of these numbers as zero, then you can't exactly look at The two numbers which used to be one is greater, one is larger, but are in the same bracket means both of them are either
Yeah,
zero.
but we are taking like k, like for all k between 1 and n, right?
I guess this idea is similar to that IMO 2021 piece, where you don't care about a lot of information you have, so you just randomly take all the big numbers and switch it with one.
You don't randomly do it. That is my
Like
point.
not randomly. You just take all the big numbers and switch it with one, so that you don't have to worry about all the other information that you don't need.
So,
Yes.
Mandar, a question about your process. Is this for a particular value of k or for all values of k?
Oh, we induct and show that this is true for all values of.
So you're inducting on n or k?
K, right?
You're inducting on k. Okay. No, okay.
This is a nice. What is this?
Yeah, sir. Can you please motivate this? It seems
Oh,
extremely
yes.
random.
Yes. So there are okay. We'll do another problem which is based on a similar idea to this.
Uh-huh.
The reason you make these ideas is wait. Have you people seen the bushy and jumpy problem?
Yes, exactly. 2021 P5. That's what I was
The
saying.
what?
You have 2021 P5.
Let me just get that problem. I
Wait,
was
is it?
originally going to take that, but then Atharva told me that he has already done it, so that is why I did not.
Yeah,
Is
so
it?
like the idea is that you have a lot of information, so you just switch it with non-less information.
See, this is usually called something called the threshold trick. The idea is you just want the last k guys to be at the end.
Yeah.
Okay, the way I motivated it was I did a bunch of small cases. And after doing a bunch of small cases, I realized that I did exactly the thing that Ridhiman was doing. I showed that 5 goes there, 4 goes there, 3 goes there, and then I'm happy. But the issue is, but the problem that comes here is there is too much information. Like if I have 3, I have to care for 5 and 4. If I have say from the numbers from 1 to 1,000, and I'm looking at the number 783, I'll have to look at all numbers which are above 783, which is a lot of casework. But then I realized that I don't really need it. I just like I don't need those cases. If he just moves to the right whenever they are larger than him, I will be happy. So I just replaced all the large guys with 1 and all the small guys with 0. Did that make a little sense?
Okay, yes.
Ah. I
Just
mean, in the previous problem, we did do something similar, right? Instead of looking at the collisions, we just pretend that guys face through each other, and we don't really care about the names.
Exactly. I mean, there is the issue here is the information we have about the numbers being the numbers they are is somewhat useless to us. It's not useless, but it is just increasing our difficulty. So we solve this version of the problem instead.
Ah, okay, nice. That makes sense now.
This is like one of my favorite problems, and I always like this idea whenever it pops up. Okay, by the way, has everyone done this problem? If not enough people have done it, we'll do this.
Yeah.
Did it yesterday.
What is
Okay.
it?
Also, is the last problem Tournament of Towns?
Now I have
Uh,
school.
I shall not release the source right now. For
Wait,
Okay.
wait,
I
I
want
already
everyone to get an
wait,
equality.
didn't I already reveal the source? Okay, sorry.
No, you did not. What? No, not this one. This one is okay. I don't care about this. This one.
Okay, this one.
so
Yes.
it's more like what you're taking is you're fixing your zeros for some k. Now
Hmm.
what you're assuming is that your zeros are already in place. You're taking care of how you want your ones to be arranged. Or suppose like numbers from 1 through k are already in the end.
No, you
That's
want to show that. You want to show that the numbers from 1 to k will always go to the end. Like all the
okay.
zeros will be at the end eventually.
Eventually. All right.
Okay, so
So
like
my question is
Hmm.
about your process.
Go on.
How exactly are you inducting on k? Like when you're inducting on something, you have your like induction hypothesis. What's your hypothesis here? Not quite getting that.
All the zeros eventually end up to the right.
So not under some number of things, some number of steps.
Eventually to the right in n-1 moves.
In n-1. So yeah, okay. So it's like this. You have the numbers 1 through k,
Yeah,
and you want to do it for k plus 1. So
sure.
what you're saying is that you know it will happen for k. You
Mhm.
want the k plus 1th guy after one more move to be there as well.
Yeah, somewhere there. Yes.
Okay. Fine. Yes.
Okay. Also, after this simplification, can someone tell me, what is the new thing we have now? Like, what is the new move that we have now?
We just swap the ones of zeros and ones.
So wait, the binary thing keeps increasing,
Therefore, the
right?
problem is pretty much done.
Yes, exactly, Vaidya. Yes, the binary things essentially just kills. Like, you can see that at every move.
The
Okay,
binary
wait,
move.
did everyone get the move, the new move that we have defined now?
No, what are you talking about? I'm interested.
See, did you get that we created this new type of moves? Did you understand? Like this new naming convention. Did you get that?
Oh, what?
Oh, so all the numbers which are from 1 to k, we named them
Yeah,
0.
yeah, I got that. I got that.
Yes. Now, after that, see, in our original thing, we took blocks of ascending guys and then we swapped them. Correct?
Yeah.
But here we just have ones and zeros. So what do you do?
So you just swap a one.
Hmm?
You just pick
You just
a
swap the one and
zero.
zero. Like anytime you receive a one and zero in a group, you swap them. Or when you receive a one and one in a group, you just keep it as it is.
Yeah, or if you have a consecutive blocks of zeros followed by a consecutive block of ones, you take that
You
entire
keep
block and you flip it.
okay, flip it. Sure.
But
Bye.
But that won't always work. Like, what if there's something like 2, 1, 4, 3,
Hmm.
and the k is equal to 2?
Uh, oh, right. Wait, I don't get that. What did you say? Could you repeat?
What if k is equal to 2 and we have 2, 1, 4, 3? Then it doesn't fully swap.
Hmm. 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 That is true. That is true. Okay. So the main point here is I wanted you to realize that we cannot really define a step here in a very nice way. Like the original steps that we actually do will be on the original sequence of number that we are given. Do you realize that, people?
Wait,
so
could you
maybe we
repeat?
can just take the steps in our original numbers and see what happens to our binary numbers in some number of steps.
Mm-hmm.
Not reflecting the steps directly after each singular step, but maybe a collection of them.
Sorry, I do not get that. Could you repeat that?
Meaning, if in our original numbers without labeling 0 and 1,
Yes,
when
yes.
you make a step, it's a step would either have after one step in our original labeling, it
Hmm.
as well be that in our zeros and one labeling, nothing has changed, right? And
That is also possible.
that will happen a lot of times. Not
Sure.
times, but it will happen.
Sure, sure, sure. Go on.
So maybe we can just try to ignore those cases altogether and try to skip something.
No, but if you skip, then you won't have n-1 moves, right? And okay, this permutation that I wrote actually achieves the maximum as well. This will require n-1 things.
Oh,
Yes. So if
right.
you ignore
Let's take
those steps,
let's
what?
take less than that.
What?
Like after like others take less than this 15432.
No, there is another one, right? Let me think.
2, 3, 4, 5, 1.
4,
Till
3,
that.
2, 5. This will
Or
take.
you can just arrange in ascending, like entirely the ascending and No, okay, with that, flip the entire thing. Sorry.
Ridhiman, you were saying something.
What if we do like a sort of cyclic permutation of the ascending ones?
What do you mean?
What do you say that?
So like 2, 3, 4, 5, 1.
Oh,
Oh, I'm not really sure if that achieves the maximum. Let's just try.
2, 3, 4, 5, 1. What are you trying to show with this, Riddhiman?
No, we are trying to achieve the maximum.
Okay,
Okay.
so this will be one. Oh no, this just dies, right? It just dies in one step.
Yeah.
Yeah, this is the
Oh,
reason why
yeah,
1,
this
2, 1,
guys.
2, 3, 4, 5.
Okay, either way, we have spent too much time on a single problem. Anyone who has like an idea of the solution or the solution, by the Varitra, anyone.
It's I think you just look at blocks of two. Doesn't matter what the value of k is. You just look at blocks of two which have 0 and 1, which have a
Okay.
consecutive 0 and 1,
Mm-hmm.
and you just flip it. You just flip them. I think that would reflect.
But how would that ensure like all your zeros are actually the consecutive integers going to, in descending order?
Oh no, that would be due to the induction on K, right?
But now you're introducing another zero to your mix. Your k plus 1 is now another zero.
No, that is okay. But see, you're now you know that in the first sum moves there is 1 to K, and in the first K plus 1 moves there is 1 to K plus 1. So the last guy has to be K plus 1.
No, say, okay. I think I'm getting a bit confused. Let me straighten things out somewhere. You have 1 through k. You know that if you have 1 through k, you can put them in the end of your sequence in
Yeah.
a k minus 1 number of moves. You know that. You
N
can do
N
that, right?
minus 1, not K minus 1, N minus 1.
N minus 1, my bad.
Yes.
N minus 1 moves.
Yes.
You know that such a algorithm exists such that they can be put away in N minus 1 moves. But now, when you're adding this another guy, how are you sure that this same n minus 1 number of moves is not changed so that your 1 through k does not stick where it's supposed to be?
I mean, it
What?
won't do the induction, right? By induction, I know that these zeros are at the right. The K zeros are at the right, which represent 1 through K. So the K plus 1th guy has to be in K plus 1, right? Because this is true for all N in this range, Ronit.
All in this range, but you only choose. But your induction argument is on k plus 1. So, how all? You
I
want to
don't
show it's
understand.
all. Okay, but okay. You're saying that you're given this k and you're trying to do it for k plus 1, and you
Yeah,
know
sure.
that there is an algorithm or a series of
Mm.
steps you can do in n minus 1 which will
Yeah,
guarantee that you have k zeros on the end.
sure.
This algorithm,
Yes.
my point is this: when you're trying to put the k plus 1th guy over there as,
Mm.
to its desired place as well, how do
Yes.
you how is how do you know that this algorithm will get your k plus 1th guy in the end as well?
Because I know that the first K guys have to be in the first K spots, correct?
After n minus 1 moves, yes.
Yes, and I have showed that the first K plus 1 guys are in the first K plus 1 spots.
Yes.
What is the
Wait,
only place remaining?
wait. 1 through k are in the same spots, then what?
1 through K are in the first K spots.
Yes.
1 through K plus 1 in are the first K plus 1 slots.
How do you know that?
Why? Yes,
Due to
yes. Why?
induction, brother. Due to induction. Due to induction. Like we haven't proven the induction. I'm waiting for you to prove it. I'll give the
Yeah.
No. By induction means what? By your induction hypothesis or by the induction you have?
by my induction hypothesis. Like see,
Your induction, huh? Okay, go on, go on.
yes. So the from 1 to K plus 1 are in the first this guy.
Why?
If my induction is true,
If your induction hypothesis is only talking about from 1 through k, yes?
brother, if my entire induction is correct, okay,
Okay, fine. Yes.
the K plus 1 guys will be in the first K plus 1.
Yes. My question was about how do you show the induction. I know why. If you show the induction, you'll get the answer.
Yeah.
I'm asking you. I thought you were talking about that. This is the induction which you're doing. This is
That is not the case. That's not the case. Either way, I'll give the proof because okay. Does anyone have the proof?
Okay, wait. This is not the induction proof, but I have another idea.
Go on.
Is it true that like after every iteration, the decimal expansion like it increases? Like, could you just go up and like I want to look at a few examples.
Sure. What K do you
Like
want to take in this
you can take
case?
1 to
K
yeah.
equaling
Look at
2
this case.
works.
The decimal number works. The increases, and it should, right? Like
Uh,
51432 like increases to 5413
yeah. The
yes,
binary number works.
like yeah, forget the binary, just look at like base 10 or base key expansion, and if we show it's increasing,
Yeah.
and I'm pretty sure it is,
yes.
Yeah.
and
But you have to
that
show
should
it
just instantly kill, right?
Yes.
n-1. How will you show it's
Wait, I
n-1?
think Bhairav had a similar idea, right? Bhairav, what was your thing?
Well, my idea was just first we say the n must go to the first one in at most n-1 steps.
Yes.
And now either the n is in front of this.
Hmm.
Wait, what am I saying?
N is on the
Okay,
front.
think this
Yes.
way. I'll tell my silly. Okay, go on.
No, I just mean the n where we prove the n will come to the front first.
Hmm.
Then we prove that the n-1 will come to the second first.
Sure.
We continue inducting like this.
Yeah, but
I
like
I
what?
had a similar idea.
You have a
Similar
Because
idea.
nice.
the n will
I
always move to the left. So even if it's at this end, it will always reach there by the end.
hmm. I agree. That works for n, but how do you show the induction?
But then for n-1, it will be moving unless it is interacting with the n. In which
Yes.
case, it will only delay it by one. Even if it's and for general, even if it's interacting with several things, then that can only move it back by the amount of those things. Meaning that
Yes.
in total, it should be there by at least n-1.
Indeed, indeed. That works. Yeah, Aritra, go on.
My basically induction step was that after like uh some m step, and
Okay.
we have the like n plus I 0, okay, from the right, let's say.
What? N plus I 0? What do you mean by that?
N plus 1 first is 0 from the right side.
Okay, sure.
For some mn, then we
Hmm.
can show that after m steps that n plus 1 0 will be uh, at the position of minimum k plus m minus 2n,
K plus
k plus m minus 2n, and comma uh, wait,
n minus m, I suppose.
yes,
Hmm.
wait, n minus m, no,
Wait,
m minus n, I think.
yes, yes. What? Oh,
Wait.
no, m is upper bounded by n minus.
Wait. If you've defined the if you're inducting on K, then how are you working with M? What's your M here?
Oh, m is the number of steps we are doing at that position, and n is like n plus 1 is the like at the first there is a configuration of like this one and binary. So the n plus 1 most 0 we are trying to watch basically, and where it goes after m steps. And basically this thing will do things if we do it by induction, which is pretty easy, I think, to do by induction.
Yes, I would agree to that. Either way. Wait, does everyone get the idea?
Not exactly. No. M is the
Okay.
number of steps for
See,
what?
yeah, I will redefine some stuff in better notation. Let
Okay.
I equal the number of steps uh we have done yet. Okay,
Sure.
done yet.
When is yet exactly?
Right now, till now. like what else does yet mean?
No. What I mean is that until we have got all our k zeros over there, or until k plus 1, I'm not sure.
No,
No.
right now, like we are doing total n-1 moves, right? Capital n-1 moves. So we
Yes.
have done I moves till now.
Okay, fine.
Okay. Now, wait, where did my pen go? So you can show that the position, you can show that the I plus first is 0. By induction, you know that the I zeros are already at the end. You can show that the I plus first is 0. Okay.
Yeah.
Not I have named it K, right?
In that
You
thing,
can-
yeah.
Yes, you can show that the K plus first 0 is in the position that is the minimum of capital N minus
K.
K, or it is I plus not I.
K.
Wait, why am I forgetting? It is N plus. Okay, I got it. Yes, it is minus 2K I N. Yes, you can show that it is in the minimum of these two.
From induction.
Yes, and this claim then finishes. I don't suppose you want me to prove this, because that would spoil the
So
problem.
that
no.
is not I plus capital N, I think. That is I plus small n minus 2k. Number
What
of
is
steps
small n?
is.
What is small n?
No, what you define as number of steps.
I.
Okay. Okay, that
Yes.
makes sense.
Yes. Okay.
Okay.
Yes. So this claim would prove the problem. I will leave the proof to you people. If anyone has doubts in this, they can DM me.
Okay,
Okay.
so like we are left with 30 minutes. What if you just pick a randomly very hard process problem?
Oh no, I don't want to do that. I at least want you people to solve one problem.
We can do 2012 P3. That is like.
That is too hard.
No.
Do it in a class. I don't want to ruin the experience.
Mandar, what if you do any one of 19 C4 or 19 C7?
This
Oh, bro, this is
isn't
easy.
this pretty famous? Like,
This
I
is-
think.
Wait,
This is
has everyone
extremely
done
easy.
this? Has everyone done this?
This is extremely easy.
Yes.
It is not easy.
No, I
It is
haven't.
somewhat
I would say this is easy, but this is pretty known.
Okay, Rudran
Yes.
has done it. Ronath, have you done it?
Yes. Yes.
Wait, who hasn't done it? Raise hands.
I haven't. Because I don't do
No.
comedy.
Raise hands who have done it. If there are more than like
Wait, how do you
4
raise hands?
people who have done
But
this,
can you define like have done it or haven't done it?
have done it, solved it before.
Bro, just count me in raise hand. I don't know how you raise hand.
Sure. So there are only 4 people. There aren't 5 people. That is why we'll do the problem.
Bro, why? Just why? Do a harder
But you
problem.
have done the
Do a
problem,
harder
Mandar, so that counts. It is 5.
Yes. Aritra. Good
You
thinking.
have the buffer problem. Do the buffer problem.
Bro,
Arey
no,
bhai,
that's too
the
hard.
rest of the time we have will be
That is
taken just
like we
reading the
can't do.
problem.
I like.
Do a
I
better
have spent
problem.
already like more than 6 hours on this problem on the second part.
I mean, you can do this problem in 4
Wait,
minutes.
someone else also told me that they do not wish to do this problem in a group. So I sadly have to do another problem. It's a good
Yes.
problem. I don't know why you people are against me doing it.
No, we can
I'm not
just
against
do
you,
this.
but like
It's a good problem, but process problems are better.
This
You
is
just asked us
this
if
is
we
a
have done it.
process. What?
You
This is
just
a
asked us
process.
if we have done it. That's all. We were
Let's
just
do
saying
this
that.
problem. This is a good problem. This is
Mandar.
probably my favorite problem.
Mandar, which one? This one.
Yeah.
Never mind.
This is probably one of my favorite combi problems.
Bro, why are you saying that for every problem?
No, this is actually I liked the previous one, but I really like this one.
I hope you don't say the same for next problem.
Oh no, next problem I'll open. I don't like that at all. So
Will there be a next
That's
problem?
nice.
Is the bigger issue.
what?
Will there
At
be
what
a
time?
next problem compared to how much we have done last time?
At what time did the classes start?
It started at like 6:05. I
Okay,
don't know.
yeah, that's why. Wait, wasn't supposed to start like 6:45 or something.
No, it started at 6:05. It was 6 o'clock problem. Like 6
I
o'clock.
just got
No, you're going on the wrong time. Okay, Mandar. Fix it and come back.
Okay, either way, does everyone understand? Okay, I'll give you a small example of the problem, what it says.
Let us
There
read
are,
it. Give us 5 minutes to read it first. Hold on.
yeah, I will just draw stuff till then. 1, 2, 3. Oh, this is the bad flavor text. The flavor text I had that they were like poker player and professional gamblers. It's okay.
By
I
flavor
haven't read
text.
the
Wait,
problem
n
yet.
greater than equal to 3. What? It's n greater than equal to 3 and you're taking n equal to 2.
By flavor text, I remember the Bhairav problem in Lamau.
Oh, right. N is at least 3. That is annoying.
Like the USA TSTST has the best flavor text after all that problem. If
That
you
is
know which
literally-
problem I'm talking about.
Yes,
Yeah.
everyone.
that love triangle one.
Which one?
Paris itself. 2011 TSTSTP5. Try that. Either way, have you people read the problem yet?
Why don't you explain us? That'll be better.
Yeah, that
No,
will
I
be
am not that in live. I mean, you can
Why?
read it
No,
at
no.
least.
This
If
gives you
someone,
this gives you a chance to introduce your own flavor text further.
I do not wish to introduce my flavor text right now. Yes,
Don't be scared of your own creations, further.
I am. That is the reason I'm not doing this.
Okay, enough fooling around for
no.
sure.
Can you cross out the pen options? I can read the problem. Okay.
Wait, so here they are referring to a configuration after some number of terms. So does the configuration mean that you take the order of all the pairs of cards that are taken by the individual people?
Oh yes, you.
Okay.
Like, see this. Say that you have 3 guys. Instead of writing the guys, I'll simply write the numbers they have. This guy has 1, 4, 7. This guy has 2, 5, 8. This guy has 3, 6, 9. This is one configuration. And this configuration is not the same as 1, 4, 8, 2, 5, 9, and 3, 6, 7. Oh,
Basically, if everyone has one of the largest end, one of the smallest end, and one of the middle end, then the largest end cycling one way, the middle end stayed in port, and the smallest end cycle the other way. So it becomes
yes, that is correct, by the way. That is correct. That's like the correct intuition. You just have to prove it now. You just have to prove that this cycle will always exist. Oh yes, Rudransh. See, do you understand what a configuration means? Just a second. Do you understand what configuration means, Rudransh?
Yes.
Okay, so TR configuration is simply a configuration, like you're given an original configuration. You do, okay, call this T0. Then T1, you apply it once. So this is the largest guy. 7. The middle guy will just stay with him. Correct? The
Yes.
middle guys will all stay stationary. This is an 8. The middle guys will stay stationary. The 7 will move this way. The 9 will move this way. And the 8 will move this way, right?
Yep.
And 1, 2, and 3 will follow the opposite route.
Mm-hmm.
So this will be T1. Do you get it, Rudransh? Like we applied it once and we get this position. We apply it in R times, we get TR.
Yes.
Yes.
Won't there be a cycle?
What do you mean?
That is what we are to show.
Yeah, you have to prove that it's cyclic, periodic.
Like zero. Okay.
You have to prove that.
Okay.
with
I
a
mean,
period of.
proving that there's a cycle is very easy, right? Because there are only a finite number of.
No, but you're given the period to be n.
Okay, yeah.
Does everyone understand the problem?
Yeah.
Arthur, Vanushka, Rithaman,
I say we should
Abhi, and
put
Madhav.
some more notation.
Oh, that's good. I like notation. Go on.
So we'll call the cards 1 to n as B track. Call the
No,
cards.
Oh
wait,
God.
I have a better
Go on,
name.
please.
I have a better name, but sure, go on.
And then, okay, so basically we keep track of the number of B track units everyone has.
That is correct. That is correct.
Then I guess we prove that eventually everyone has one, and then we find the amount of time for that. And we meanwhile
Yes.
take off for Z track units also.
Yes.
And then that it will finish the problem.
It will
So we just
finish.
so then
That is
for
indeed.
so now we've reduced it to a smaller game where everyone has a number
Yes,
between.
just it's okay, Bhairav. I get it. You understood the problem. Did you try the buffer problems? Let us give have some time to think. Yes, you can DM me the solution as well or anything else. Does everyone understand the problem, by the way? Akshar, Rudransh, Aryan, Arav, everyone.
No.
Okay.
Get what Bharat said.
What problem? What part of the problem do you not understand?
No, I understood the problem. I didn't get what Bharat said.
Oh, okay. So I think you should think on that a little. Like think about the problem a little bit more on your own. Then saying it will be more beneficial. Directly telling you the idea won't help you that much. Just think for it like 5-ish minutes more than I will tell you. No, Aritra, this is not something we group solved. I told you this was one of my favorite problems back then too, but yeah, this is not something we group solved. Oh, do people okay? Has anyone seen this problem other than Aritra?
I don't think so. No, not anyone.
Okay, wait. Is it true that once this 1, 2, 3 gets passed out to everybody, it just cycles? I think that's true, right?
Yeah, that is true.
Like once it gets passed out to everybody, it cycles. So you have to
Yeah,
show that somehow it gets passed out to everybody.
exactly. That is correct.
You're saying the B, yeah, okay, bare of notation stuff. You're saying the B track is always cycling. Is that what you're saying, or am I getting something
Yes,
wrong?
that is what he's saying.
But like, how are you not sure if maybe someone in the B track is your middle card?
Wait, run it. Let me write down the entire thing, then you will understand.
I see.
One card of B track,
I see. Okay.
then the B track cycles.
Yeah. Similarly for Z also, I think. Yeah.
Yes.
Yeah, that's also Z, correct.
Yes.
Okay, wait. By cycles, you mean everyone gets.
If this is the case, then like
What do you mean by cycle?
Like it just suppose in this case they are in a side, like see, every guy has one of these, right? 1, 2, 3.
Yeah.
In the next move, the 2 will go here, the 3 will come here, and the 1 will go there. Correct?
Yeah. Yeah.
So after 3 moves, it will be the same as it was before.
Yes.
That is what they mean by cycle. It just cycles in like it is periodic with a period of n.
it's like one of those old telephones, and you're moving around the number
It's
the
not
number
the old
plate.
telephone, right? Because when you do this,
Isn't,
it goes back this way.
Yes.
isn't there
So
something like
like only do it in one direction, and you have three of them. So
Yeah,
every
essentially, practically. Yes.
yes.
is
Okay.
it like very obvious? Like with cycles?
People
Like
understand why we have done this. Rudransh, Anushka, Arav, Akshar, and other people.
wait, isn't it like
Yes.
extremely obvious? Both of those cycle like
They are obvious, but you would want to show that this happens because then you know that there will be a cycle of length and only.
So you want to show that that should exist, that each set should have one of the cards in the tracks, right?
Yes. So essentially, you want to show that after n minus 1 moves, every guy has one card from track B, track D, and track Z.
Wait, after n minus one moves, what? No, I think like eventually. Right.
Eventually, that's what I was thinking as well.
Okay, you can prove. Okay, let's just replace the problem from eventually to n minus 1 because it's a stronger form.
Okay, fine.
Oh, okay.
I don't think n minus 1 will be the optimal bound.
It is actually, I think.
It is, but I'm not sure how to prove it. I'm like stuck on that.
Oh, what's
We
your
could
idea?
probably just give 2 to one person and then 1 to all the people and 0 to this person.
Uh,
Yes, I think that will work.
Wait. Could you repeat that? You have 3 people. Give me the construction for 3 people.
So basically, for this person, we give 1, 2, and 4.
Okay.
Now, for the next person, this side. Wait, which way do the smaller numbers go? I forgot which is counterclockwise, which is clockwise.
Oh, I also forgot that, but we'll just use the notation we have been using before. Okay, so the big numbers travel this way, and the small numbers travel the opposite way.
Okay. So now for the
Go on.
person on the right, we give 5, 7, 9. No, we give 6, 8, and 9.
6, 8, and 9. Sure.
And then we give 3, 5, and 7 to the other person.
3, 5, and 7 to the other person. Okay, let's just see. This is T0. Let's just calculate T1. So 2 remains at 2. 4 goes here. And 8 remains 8. 6 goes, no, 9 goes here, right? 9 goes here. 5 remains here. 3 comes here. 6 goes there. And now 7 goes here. 1 comes here. So, and then we do this again. This is correct, right? I did not make any calculation mistakes, did I? 6. Wait, is someone checking my calculations? I would like.
Is it, shouldn't 6 be in the position of 7?
What do you mean by that? No. See, the small ones rotate this way. Like the small ones follow the rainbow arrow. So 6
I
will go
mean,
up.
why something like 1, 2, 3, 4, 5, 6, 7, 8, 9 doesn't work? That construction also should work, right?
No, I don't think that will work.
Because the ones are moving, if that is like less than n minus 1, so like, okay, no, that I am not sure.
Wait, why
That
are we
was
constructing this? What are we constructing?
Bhairav is saying that the bound of n minus 1 is actually not correct. So I'm testing that out. See, the
Wait, this
middle guy
already
is at
has
6.
B. This has a B track unit everywhere and a D and a Z.
Yes.
Yes,
No,
I
this
think
guy
you
does
might have
not have. Oh, we are already done,
We're
Bhairav,
already
right?
done. Like, what are you missing? Let
I
me see.
might have mixed up something. Okay, can we change counterclockwise and clockwise now? I think I gave my construction the wrong way round.
So swap left
Uh,
and right, I guess. That should make
Let's
that
swap
should.
1, 2, 4, and 6, 8, 9. I think that works.
no, that doesn't work. I'm sure that n minus 1 is indeed the bound. You can try
yes,
that.
like that was the actual
Yeah.
paper question,
Yes,
I think.
for 1, 2, 4, and 6, 8, 9, if you swap them, you get the construction for n minus 1, I'm sure.
Sure. Okay, no, what do you mean by n minus 1? I say that after n minus 1, it will simply be like one guy will have B track D and Z. Like each will have one of B, D, Z. I don't say anything more.
Yes, I have a construction for n minus 1 in that case. That is this thing basically.
Oh yeah, okay, then it's fine. I don't think we have any issue.
It's
Does everyone
supposed to-
understand what we are trying to do?
I made a mistake and swapped a 1, 2, 4, and 6, 8, 9.
I was actually rather looking at triples where you start off with say you start off with a guy who has two B units and one something else. It could be a D or a Z.
Sure.
So I am now looking at how n-1 moves. You can get that evenly divided now.
What do you mean by that?
What I mean by that is that if I have, say, okay, if we have two B units, then we know that they must be the two smallest ones,
Sure.
number point of view. So I'm just looking that how many times at maximum would it need for that particular group
Yes.
to be rid of to be completely like to have one B, one D, one Z.
Mm-hmm.
That's just what I'm trying to see. What's the maximum?
Wait, didn't I tell you the answer already? It's n-1.
No, but why is it that? I'm just looking at that. Why should it be the maximum? That's what I'm looking.
You're looking at the exact same thing as we are, right?
I was not quite sure. I was just trying this.
Sure.
So you were trying what?
Okay, in at most n-1, right? Or in
Yes.
At most, yes.
Instead of eventually replace it with n-1.
Yeah, exactly. That's what I'm trying to see. Why does n-1 come up? So that might help
I
me.
mean, no, if you get why it comes up, then you'll be done with the problem.
Exactly. So that's what I'm trying.
Okay, wait. So why do we even care about the other units? Just care like the number of B units each person has. And
Good.
then,
That's a starting point.
Exactly. That's what I was trying. So,
Sure. Yes, Saritra, you're saying something. I don't know.
I think I have like a crazy idea. Should I tell?
If it is too crazy, then sure, yeah, like go on. Go on.
I mean, what we can do is like keeping the minimum card to themselves. Uh, I don't know which is right and left. Like, give the maximum cut to right, I think, and median cut to on the left, and change the players' names. So after like n moves, that will be kind of symmetry. And you have like if you can prove that after like this is also periodic, then that problem is also proven with that. Like both of these problems are equivalent because after n
Okay, I
moves,
understand what you're saying. Yes, yes, I
they come
understand
back
what
to
you're
a
saying.
cycle, the names.
Yes, yes, I understand what you're saying. Did the other people get what Aritra was saying?
but we have to change the names,
Wait,
right?
no,
Like
can you
that
explain
gets.
again what you said?
Yes, I will repeat that. So what he essentially said, okay, suppose that the big cards go in this direction, okay? Suppose that the big cards go in this direction.
Okay.
So what you do is after every move, you take the people you have. Suppose you have person 1, person 2, person 3, person 4. You move them in this direction as well. Like you simply change their names. You move them as well. Okay. So now what it does, keeping the cards fixed, like get something. So now you have a new operation. What it does is you have a person 1 who has the smallest card, the middle card, and the big card. What he does is keeps the big card to himself. Keeps the big card to himself. He passes the smallest card 2 blocks this way. Okay. Whoa, it does this. I did not know that. He passes the smallest guy 2 blocks this way and the middle block one guy this way. Like just one times here. Passes the smallest guy twice and the middle guy once.
I mean, you
Did
can first pass the card and then change your like the person don't change the labeling change. First pass the card and then change the labeling. That is better. Like you don't have to do 2 blocks and other stuff. I mean,
but then you
Why
will
would you
eventually
even
have.
do this? Why would some
How is this motivated? Like 2 blocks and 1 block?
Yeah. So the point is this thing that you're doing, you're keeping the middle to yourself and then you're taking this guy here and this guy here. It is in some sense a more complex process than simply taking the two guys and sending them to one side. Um, because what you see is you are giving it to both directions. If you just give it to a single direction, cycling becomes much more natural, right?
Yeah.
Yes.
and
Did
also the thing is like like if you have the smallest card or biggest card on you, after a certain time, like that will be fixed. Like you can't change that. But the middle card is like a lot changeable depending on the cards. But smallest and biggest card will be fixed after like
Yes, yes, indeed,
if it goes well.
indeed.
Like that will be 1 to n and like n plus 1 to 2n plus
Yes.
1 to 3 basically.
So in this one, you essentially want to show that after some amount of moves, everyone will have one of the B tracks because they hold on to their largest guy. You want to show that eventually they will have a B track. Everyone. Does everyone understand what we did? And does everyone also understand why we did?
I
I
mean,
get
the persons are going in the opposite direction, right? So doesn't it just beat the same direction thing?
I don't get it. What do you mean?
Wait, you said the motivation for doing this more complex thing is that you're
This
sending
was a
the cards
less
in the same
complex thing.
direction.
No, yes, yes, I agree.
Yeah, but like the people are going in the opposite direction.
No. What I
What is
do?
hard?
Oh no. So what I do is okay. What Aditra does is he firstly sends all the cards out the normal way, like largest this way and the smallest this way, and then he rotates all the people. Does that make sense?
Okay, wait, and why do we rotate the people then?
Because I want to keep the maximum card I have with myself. I don't want to change that in. Like the largest card I hold will always be with me.
Wait, but why does it make a
Okay,
difference? There
yeah,
we are
but why
holding the
does this?
median card. We are holding the median card there. Here we are
Median
holding the
card
largest
is
card.
like bad and like small and big
Yes,
cards are good.
because see, everything we have here is about B and D tracks, right? So if we are holding on to D tracks, that is somewhat clunky to work with. If I hold on to the largest guy, I just want to show that everyone will have a B track. If I have a middle guy, I have to show two things now.
Wait, why do we need to even show? Why can't we just take the normal thing and consider only the B tracks? Like we don't even need to consider Z tracks, right? We show that the B
Oh,
track
that
go in n minus one time. Then naturally by symmetry, Z tracks will also go in n minus one time. So by
D
that
tracks
table,
you can't say that. You can say that for Z and then like due to
yeah,
it
B
will
and
be
Z, that's it.
yeah, makes sense.
And then that means D will already be distributed. So why do we need to make such a complex process?
it,
Uh,
it
hmm.
it doesn't matter if you're
This
doing it with Z or D. I mean, if you know that one guy
Exactly,
is
we
being
are. We
distributed
just
with
need one
everyone
of those.
else, exactly.
I
So it doesn't really matter. I should say. I don't understand why you want Z instead of D. Maybe you want to say because D is your middle guy
because
is
median
not
card is
changing.
changing, and if you see small card and big
Ah,
card after some finite, like after n plus 1 type of move, that's why the n minus 1 comes up. Uh, like they're fixed, they don't change. Like if you have the small card, they will remain to you for the like remain to that position, not to you because I am changing the version, but
no,
they
but
will remain to that.
Yeah, but middle card also remains the middle card after finite, like after the periodic thing starts, right?
more than that, in
Will
your
you?
process
No,
as
no, no.
well, your big
If
card
you
is
see the
not
median card,
always.
like if you don't chase the person, the median card actually like don't stay to you. Like they rotates and come back to you. But here the like they always stay to that position. Like they're periodic with periodicity one basically. And after like n moves, they all go to the same position. So like because you are considering like mod n or whatever you are doing, they like preserve the person. Like this is like you don't have to show like much claims here. Like both the things are same, but here like two claims will be like done, like if you show two claims.
Okay,
But
wait.
see,
Why does middle, like in the original thing, why does the middle card cycle? Like you keep the middle card, right? And the middle card is always more than a B track
But
and
like
less than a
that
Z
middle
track.
card, you get a card which is like bigger. So like
Wait,
then middle card, that middle card becomes the smaller card and you change that card. But the
no, but
smaller
like
card
you will
never
also get
becomes
a
the
smaller
bigger
card,
card.
right? Any card in the B track is like more is less than the middle, and any card in the Z track is more than the middle. So the
I
middle card always stays the median value. It doesn't like so you always keep
But
it.
a person can have like two things, right? I don't get that. I
two
don't
Bs
get that
and
Yeah, no,
logic.
but
something
we are
else.
like once you have the periodicity, then no.
I think more than that, like you're saying that because the middle guy is like crazy to work with because it's changing all the time.
wait.
I- I'm I'm saying that your
Hold on,
B need
wait.
not always be as
Hold
what
on,
now?
wait. Yeah. Okay, Gupta, we are doing this problem. You can take a screenshot. Okay, I suppose. Okay, also Aryan, what are you not under? Like, why? Where are you lost in this?
I mean, I didn't understand the process, so I have to do it myself to understand.
Oh, okay, sure. Yeah.
Also, like,
I
why are
thought.
you saying that the middle card is changing? Isn't that bad to work with? Like, we don't know if it's changing.
Sorry, I could not understand that.
I don't get why you're working with the middle card. Isn't it bad to look at? Like, you don't know if it's changing or not. Why are you saying that it's changing?
Oh, the middle guy. No, Aritra is saying that the middle guy can change. Like the middle guard can change potentially, and that is why you want to look at this other process.
Okay, but
But
like in
like,
the end, we have to look at the middle card. Like, we need a D track, right?
oh, not really. If you have a B track and you have a Z track, the D track will force itself. Like, if
Wait,
every
why?
guy. Oh no, see, there are n people and there are n like B tracks. If each guy has a B track and a Z track, okay, then only the D tracks are left and everyone must have a D track as well.
Okay, yes.
Okay, let's define a simpler process now. We only look at the number of, say, B track units because B and Z are symmetric. And then,
Okay,
so if a person, and then each person gives out one unit. Like, obviously, one B track unit will move out of its place, right?
sure.
Each person. So, like, if that person has a B, that is. So, we just need to look at whether it'll all become 111 eventually.
Correct.
We need to just look at the number of B track also, like.
Sure.
So, our simplified process is like that.
Yes.
Okay.
So, like in the previous problem, can we just replace all B tracks with like zeros, D tracks with ones, and Z tracks with twos?
Yeah, you can, but you don't have to.
I was looking at the
Yes,
number of B tracks of each person, not exactly.
yes. Rhythm. So what he's doing is instead he's only focusing on the B tracks. He's like, I don't care about anything else. What happens if a guy has three B tracks? He sends one of the B tracks here and one of the B tracks here, and now he himself is left with one B track. If he has two B tracks, then he sends one B
One,
track
yeah,
here and
exactly.
himself is left with one guy. And he just has one guy, so he just sends it here and is left with zero.
Yeah, the issue, like the thing I find tricky over here is when suppose you have two B tracks and the person who you're giving your smallest B track to has three B tracks. So he's gonna give you another B track back and you end up with the same number of B tracks. That's what I find
Sure.
a bit tricky. I
Hmm.
was trying to work around that. That's what I was trying to say before.
Cool, cool, cool. Regimen, do you understand?
Yeah, it makes sense.
Yes.
Wait, but if the person next to you has three B tracks, then like he himself will reduce like to two, right? If
No, no,
somebody has three, he reduces to two.
no.
Not
Yes.
necessarily, right? No.
No, if
Why?
somebody has three, he must reduce to two, right?
No, that is false.
Okay, can you show me where it's
But
Uh,
if you have like two, you have a person with two,
three
a
three
person
three.
with three, and a
Just
person
take
with
three
two,
three three. Brother, just take 333.
and
Both
look
of
at the
them.
okay,
middle
okay,
guy.
that way.
So
Okay,
if
but
you
the
say,
threes at the ends of this three sequence will reduce. The threes at the
Yeah.
end of this three sequence will reduce.
Yes. Yes.
so we can look at chains of these. We know that the chain can't be the whole everyone in the circle. We can look at chains of these people which have more than one B track, say.
Okay. Sure.
And now let's look at suppose we have a string of these people which have either two or three B tracks. Now we know that the end guy is
Hmm.
going to be -1. It has to
Okay.
be the number of B tracks he has. Say everyone has B1, B2, B3, B4. Okay, and then
Yes.
in your string you have people from BI to say
Hmm.
BI plus K. Now you know
Okay.
that BI plus K is going to be -1 because that's a string and that's the end of your string. So you must have another guy after uh, the I plus K plus 1th player who's going to not have either two or three B tracks. Yes.
Sure. Sure.
So now let's look at that maybe getting from Nishant's idea.
Hmm. Hmm, hmm. That's an interesting idea.
Wait, can we do this? Like, we will say a hand is like dead if it doesn't have any B track. Then,
Sure.
like, some B track will cycle.
What do you mean by some B track will cycle?
Like, some B track will like move among every hand.
Why?
Like, let's uh, say smallest card is stays, middle card go right, and like the largest card to go to right,
Hmm.
and then the some like at a starting. Wait, wait 1 second.
Yeah, you can. Nishant, you were saying something.
Not really.
Okay, sure.
One thing to clarify, the thing I did, can't you
Yes.
just do that to like smaller numbers and bigger numbers and say that like both of them will be same after n-1 moves?
Yes.
Because essentially you're not changing and the middle cards will stay if like both of those are same. So like that just finishes.
It does. I agree.
Yeah, basically, let's say at a start,
Hmm.
someone has a two beat track, then one
Uh,
beat track will
at
like
the start or at the end of at the end? At the
at a
start or at the end? Okay, sure.
at
At
a
the start, one has two B tracks. Sure, go on.
then one of them will go right,
Okay.
will go to nest, then like oh,
And one of the B tracks will stay.
yeah, wait, sorry.
Sure. Hmm.
Okay, maybe instead of looking at strings of people who have more than or equal to two, let's just say strings of people who have at least one B track. So
At
we're
least.
now so we're now going to look at those people who have
Hmm.
a B track. We're basically what we're doing. We're differentiating the people who have a B track and who don't have a B track.
Sure.
It's so now let's look at maybe a string of these people. So suppose every person was numbered 1 through n, and
Yeah.
our string and every person has bi number of b units. So
Sure.
let's look at the string with suppose a string goes from I to I plus k.
Wait. You have person one through person two till person I, and they have B1, B2, BI, B tracks.
Yes. So suppose there is a string
Hmm.
of these such that the bi's are positive. So suppose that's from bi to bi plus k.
BI plus K. Okay.
Bi all the way to bi plus k. All of these people are in one string who have at least one bi.
Wait, the B1 through BI are the people who have at least one BI. You might as
No,
well
no.
define
I
it as
mean
zero.
b. Okay. ba ba is the number of b units uh,
Sure.
eighth
The
person
eighth.
has. That can be zero as well.
Sure.
So I'm saying guys from BI to actually B1 to BI also works. It really doesn't matter.
Exactly. Exactly.
Sure, sure. I was working with yeah. So B1 to BI, we have all of these people in a string. Now note that if our string
Hmm.
happen to be the whole circle, we are done.
Sure.
So now let's just look at one of these strings. Now we
Okay.
know that BN
Hmm.
and BI plus one don't have a B unit
Uh,
unless they are the same person.
sure.
Suppose
In
they
which case
aren't,
we are just done. In which case we are just done.
Sorry?
In that case, we are just done, right?
Yes, so they have to be different people. You're right.
Wait, are we done in that case? Yes, somewhat.
Yeah,
Like, we'll
because like there will
If
be
they're
one
the same
extra.
person, then yeah.
There will be one extra B track in the middle of the string, and that will
Yes.
easily move to the ends.
Indeed,
Yes.
indeed.
Like we can show that.
So you now have this BI to BI, B1 to BI string, and B0 and BI plus 1 do not have any. Now let's look
Okay.
at the circulation of B units after one movement.
Sure.
So now we see that, okay, which way are the
This guy has
B
0,
units
right?
going?
This guy has 0.
Which
So this
yeah,
guy
which
gets
way are the
1.
B's going? Which way are the B's going? That way. Okay, sure. So we now know that B0 has one guy. B1, B2, they are all staying constant until BI minus 1.
Correct. That is all correct. Then here it will be -1, and you will have BI plus something. You don't
BI.
really. Let's just call it BI plus 1 dash. You don't really know.
What is BI plus 1 dash?
You don't know if the BI plus 1th guy gets a B unit, right? It might or it might not. You can't say much.
It doesn't get a B unit. It might have one from before.
No.
No, it might not, right? Because BI plus 2, it all depends on if BI plus 2 has a B unit or not.
Wait, hold on. What happened to BI? Just asking. What happened to BI?
BI got reduced by 1.
BI got reduced by 1. Perfect. Yes. So now
Unless
you're
BI
saying
had 3. Unless BI had 3, right?
unless BI had 3.
3 previously.
3 B
And it
units.
reduced by 2.
Correct.
Yeah, that is correct. This or
This. Yes. So
oh no, yeah, that is
it's just
sure.
no. It's just BI minus 1. It's just BI minus 1.
Wait, why?
Why?
What?
How you get BI minus 2?
Different
He has
3, no?
3B. He has 3B units. He sends one guy here, doesn't get a B unit from here, doesn't get a B unit from.
Yes. Okay. So and now you say you have BI plus 1 is now BI plus 1 is also having a B unit. It has to have a B unit. I think, yeah. Or no?
Not necessarily.
No, sorry, my bad. Yes. BI plus 1 does not get any other B unit unless BI plus 2.
Yeah, that is true.
That is true. Okay. So now my thing is that if we can show that doing this multiple times,
Yes.
we have that the chain sort of reduces, or at least the total value of all BIs in your chain reduces. Either one of them, maybe that will give us some.
You want the chain to increase.
Yeah, sorry, the chain to increase and the kind of say average in your chain get closer to 1.
Okay. Yes.
So this is what I'm trying.
That is good. Just a second. Let me read the chat. Paris, I don't really get your solution. Could you repeat?
Yeah.
Oh, wait. I don't think okay. Do people want me to discuss the solution now, or do they want to try it on their own?
No, not exactly. You can discuss. We can mute maybe.
I don't know. I will at least try to.
Okay, Paris, you can just DM me the solution. That would be better. I suppose I'll end the class now because everyone is done. Okay, I'll just tell you the sources so you can check it for yourself. Let's see. I hope I remember the sources. This is Elmo 2019 P3. This one is Tournament of Towns 2015 Fall Senior. Bro, this is too long to write. A.
Just like TOT 2015.
I agree.
They
I
will
should have written
scroll
that.
Yes,
finally.
Aritra. Congratulations, your guess is correct.
Classic.
Sad. I guess the US.
These are the
What?
sources. You may check that. I will buy YouTube people.
But
Yeah, done. That was the class.
Bro, the
Wait,
recording is
actually,
not done.
just me, or does Anushka sound like Tanishka?
The recording is on.
No, recording is off. Recording is off.
No, it's on.
It's on. It's on.
Oh, did I pause it?
You
No.
didn't close